most probably have 1 or 2 classes per week, right?
Yes, ma'am.
Fine. Today we'll continue with this, and whatever I'll discuss this with the team. Whatever the thing is fine, and then we'll go accordingly. Okay.
Okay, ma'am.
So yes, for compounds, any problem in the elements, Bacha?
No, ma'am.
Fine. Now, what are pure substances basically? What
Substances
are
that are
pure
made of the same kind of particle.
same kind of particle? We saw that in case of elements, the same particle is nothing but the atom. It is being continuously repeated, the same particle, right? The same
Yes, ma'am.
atom. Because we say atoms are nothing, but when same atoms combine together, we get the element. Yes. And
Yes,
that
ma'am.
is why it is defined that elements cannot be broken down into simpler substances because it is made of just one atom. What will you break it into? So it is made
Yes.
up of same atoms. You cannot break them into simpler substances. It is already in the
No.
simpler substances. That's atom, right? Now that's it.
Ma'am, but
Now
can
the
we break an
elements
atom
based on
into
the
subatomic
properties
particles?
that is there, but electron, proton, neutron, they are existing within a atom. They will not have any property as such on their own. Like atom
Oh,
together will have some property, right? Are you getting this? Like example, let's
yes,
take
ma'am.
one iron atom. It will still have the properties of the iron element when many iron atoms are there together. But one electron of the iron atom will not have the properties of the iron atom or the iron element. Are you getting this point here?
Yes, ma'am.
Fine. Now, coming to the next part, okay, I was saying that elements have been divided into 3 categories: metals, non-metals, metalloids, based on the properties that they possess. Simple,
Yes, ma'am.
right? Now, coming to the compounds. Compounds are defined as molecules. That's fine. Molecules again form the compounds. But in this case, the molecule is having 2 or more than 2 different types of atoms or elements. If I'm referring to elements, please know that I'm referring to atoms. Please know if I'm referring to atoms, I'm referring to elements. I hope that is clearly understood.
Yes, ma'am. Yes, ma'am.
Good. So when I'm saying that 2 different types of elements are combining together, or atoms of 2 different types are combining together to form the compound, why am I saying that compound is a pure substance? And that is because that is because the elements are combining in a very fixed ratio proportion. Therefore, they are forming a completely different particle. And if that particle is being repeated, we get a pure substance. Example, H2O is a completely different particle now. Although it has been formed after the bonding of hydrogen and oxygen, but chemically in a fixed ratio. And when we get H2O, the particle of H2O has completely, absolutely different properties from that of the constituting elements, which is hydrogen and oxygen here. Therefore,
Yes, ma'am.
we say that we get a completely different particle behaving as one particle here. This
Yes,
molecule
ma'am.
of water here, which is a compound, although is behaving as one particle here. If I have got 10 molecules of this water compound, yes, I have got the same type of particles here. Because in every
Yes, ma'am.
particle, I will have 2 atoms of hydrogen, 1 atom of oxygen bonded together in a fixed ratio chemically. That's it. Having completely different properties in hydrogen and oxygen. Therefore, that is the point here in the compounds. Is it understood?
Yes, ma'am. So it's made of the same
Fine.
type of molecule.
Yes, same molecule. That's it. Just to understand in the simplest forms, we can say that the same type of particle in case of compound is nothing but the molecule. Is nothing but the
Yes.
molecule, right? And see. Second, what are the properties of compounds here? Properties of compounds. See. First, when two or more than, I'm writing like in a quicker form, when 2 or more than 2 elements combine together, okay, what is the nature of bonding? Chemical bonding, right?
Chemical
Chemically,
bonds.
in a fixed
Ratio by mass.
ratio or proportion, okay, proportion and fixed composition by mass, okay. That is the first point, okay. Second, what is the second point? The properties of the formed compound will be completely different from that of constituting elements? Yes, Bache. The third
Yes, ma'am.
point, see, if they are bonded chemically, if we need to separate them, we will obviously need chemical methods of separation. I'll explain you this. Chemical needed to separate. See, Bache, the point that I'm trying to make here is this. If this is H2O, okay, this is H2O. If I just talk about H2, Bache, we know this H2 is an element and it cannot be broken down into simpler substances. Simpler form, right? But then if I talk about H2O, we know that it could be broken down into simpler substances. That is elements. And what are the combining elements here? Hydrogen and oxygen. We know that the compound can be broken down or decomposed into its constituting elements. Yes. So therefore, if I break this, or if I separate this into its constituting elements, can I say I will get hydrogen and oxygen because those are the two elements combining? Yes. And what is this process called as? What is the process I'm using here? That is electrolysis. That is electrolysis. Lysis means to break. See, lysis means to break.
Break.
And I'm breaking that H2O molecule, okay, using the passage of electricity or electric current. That's it. So
Okay,
therefore, electrolysis, breakdown in the presence of electric current. Okay, that's it. Okay. Now I'm breaking this, and this is very clearly a chemical method of separation. Chemical method of separation. Filtration is a physical method of separation. If you filter water, can you get hydrogen and oxygen separately? No, we
No.
still get water. Why? Because it has been bonded chemically. It is one particle there. We cannot separate them apart from the chemical method. Are you getting this?
Yes,
Fine.
ma'am.
And therefore, electrolysis is a chemical method of separation. And two important points regarding electrolysis, because this is very importantly mentioned in the NCERT. Cathode.
Anode.
Yes, cathode and anode will be there. Cathode being the negatively charged. Cathode being the negatively charged, we will get hydrogen on the cathode. We will get H2 gas on the cathode, okay? And we will get oxygen on the anode. Yeah, fine. And let's suppose the next point important here is that what is the ratio of hydrogen to oxygen obtained? What is the ratio of hydrogen to oxygen obtained when water molecule is decomposed? And the ratio is 2:1. Hydrogen to oxygen is 2:1. This is the ratio. Yeah. And why do we
Okay.
get this? See, why do we get this? If I write this, okay, one water molecule here, I have one water molecule here, and I will get H2 plus O2. Okay, I will get H2 plus O2. Now this is not balanced. So to balance the equation, I will write this. Okay. Now this is a balanced equation. So when two water molecules are decomposing, okay, we are getting two molecules of hydrogen and one molecule of oxygen. Yes.
Yes, ma'am.
So therefore, what ratio do we get? 2:1. You can clearly
1.
see hydrogen is twice the amount of oxygen here.
Yes.
And one important point here is that the question might be asked in this form when we will be getting, let's suppose we are having these electrodes, okay, and on these electrodes we'll be having the test tubes. The amount of hydrogen, let's suppose this is the cathode, okay, the amount of hydrogen will be double to that of oxygen. Why? Because it is 2 times the amount of oxygen here. Any problem in the electrolysis part?
No, ma'am.
No. Should we move on to the
Yes,
next
ma'am.
part? Fine. Can you give me, see, last point here is that when we were talking about the compounds, we said that they are in a fixed proportion or fixed ratio by mass. Now, what is this fixed ratio by mass? Although we will discuss on this very clearly in the third chapter, but since here it is mentioned, see, if I take H2O, I am saying that the number of atoms from hydrogen and the number of atoms from oxygen combining together will be fixed for this water molecule. Yes, 2 atoms of hydrogen and 1 atom of oxygen. This is very obvious. If the number of atoms are fixed, the mass because of those atoms will also be fixed. Yes.
Yes, ma'am.
Yes. So therefore, the ratio by mass, I am saying I am getting 2 units of mass from hydrogen. Why? Because the mass of one hydrogen atom is 1 U. How many atoms of hydrogen are here? 2. Yes, leave the
2.
unit as of now. 2. This is very clear. And only one oxygen atom is there. The mass of one oxygen atom is 16. Can I get the simplest ratio as 1:8?
Yes, ma'am.
1 time of hydrogen and plus 8 times of oxygen will give you 1 molecule of water by mass.
Yes, ma'am.
So this is the ratio. This is important. This is important, the ratio when you get after the electrolysis of water and what gas is obtained on what electrode. These 3 points are important. That's it.
Yes, ma'am.
Fine. Now, so basically the compounds is also completed. Any problem in the pure substances part? The
No,
elements
ma'am.
compound. Fine. Can you quickly just brief me some of the properties of the pure substances based on whatever we have discussed here?
Pure substances are made of only one particle.
One type of particle.
One type
Single
of
type of
particle.
particle. Okay, good. Second.
Pure substances are made of one type of particle, and
Mm-hmm.
pure substances
They have
pure
a definite
substances.
set of properties. Yes. Why? Because they have a
Yes.
definite composition. And if they
Yes,
have a
ma'am.
definite composition, they are bonded chemically. If they are bonded chemically, they cannot be separated by physical methods of
Physical
separation.
methods.
Yes.
Yes, ma'am.
Is it clear? Should I write all of this or you are
No,
okay
no,
with it?
no. I'm okay.
Fine. The next that we are going to start, we'll go through the NCERT first. See, in a fixed proportion, chemically combined with other element in a fixed proportion. Okay. Now here two things are important. The activity. You will go through this activity. I'm not discussing, or should I discuss it right now? Whatever is your call.
No need, ma'am. It's okay. I'll look
Okay,
at it after.
you will go through this, okay, because it's really important. Many of the questions are based on just this activity. Okay. So you will go through this, then we can discuss this. Else everything has been discussed. Elements react to form new compounds, fixed composition, completely different properties, can be separated by chemical or electrochemical reactions. Clear? That's it. Now coming to the impure matter. Coming to the impure matter, which is referred to
Mixtures,
as a
right?
mixture. Good. Which is referred to as a mixture. Now, mixture first, we will discuss mixture and then I think everything will be clear. Mixture is nothing but when two or more than two pure substances, right? Two or more than two pure substances are mixed together. By saying mix, I mean they are bonded physically. There's no chemical bonding there, right? Mixed together in a by physical nature of bonding, okay, in a variable composition, in a variable
Variable
composition.
composition.
And the properties, let's suppose I'm mixing A is a pure substance, B is a pure substance, okay. I will get AB as a mixture. I will
Yes,
get
ma'am.
AB as a mixture. Now this AB will have the properties which will be a result of the properties of A and B. See, this point is completely different from that of compounds. Compounds are having completely different new properties. Here, the mixture is having the properties as a result of the properties of the components. Yes, the
Result
components
as
which are
their result as in they're similar or they're exactly the same as both of them.
mixture of both of them. Mixture of both of them.
Okay.
Okay, that is why we are calling it as a mixture. Fine. So this is the major point here. It is a variable composition. Variable composition. Okay. So that's about a mixture. Should I write the points or you are okay with it? Whatever is
No,
your
ma'am,
call.
it's okay.
Okay, fine. Now, when I talk about mixture, can you quickly give me some examples?
Um, Milk,
Mm.
butter, yeast, smoke.
What else? Some simple examples. Come to some simpler examples.
Simple example.
Mm-hmm. Very simple so that we can discuss on that
Salt
and then we'll.
water, sugar water.
Exactly. Salt water, sugar water. So sugar is a compound. C6H12O6, glucose, right? That's a
Sucrose.
compound. It's a pure substance. Water is a compound, again a pure substance. If
Yes.
we mix both of them, we get a
They
mixture.
become
We
a
are not
mixture.
bonding them chemically. And secondly, we can have a variable composition. You might add 2 tablespoons of salt in 1 glass of water. I might just add half tablespoon of salt in 1 glass of water, right? It is still
Yes,
the
ma'am.
salt water, but we are having a variable composition there, right?
Yes, ma'am.
Secondly, the properties are a mixture of both of them.
Yes,
Both of
ma'am.
them, we will have the liquid, but a salty taste, right? A
Yes, ma'am.
salty taste of the liquid. So that is the point here. Now, coming on to the next point, that is regarding the types of mixtures. Any problem in the mixture part, Bachan?
No, ma'am.
No. And also very important, since they are physically bonded, I think you will understand that they can be separated out using physical methods of separation.
Ma'am, not all of them, right?
Physical methods of separation. I'm coming to your question. I think I've understood your question, and that is, see, but filtration is a type of physical method. Evaporation is also a type of physical method. Distillation is also a type of physical method. Okay. Let's suppose you're talking about something which is not getting separated out using filtration. We can have other
Yes, ma'am.
methods which are also physical methods. Example. Let's suppose salt and water mixed together cannot be separated out by filtration. I think you were asking this point, right?
Yes, ma'am.
They cannot be separated out using filtration, but
But
we
they can
can
be by
very
evaporation.
exactly evaporate. Okay. So we are not sticking to just, we are not saying just by filtration. I am saying by any method, but that should be physical in nature. Yes.
Okay, ma'am.
I hope the point is clear.
Yes, ma'am.
Fine. Now see, mixture again is of two types, homogeneous. Okay.
Heterogeneous.
Hetero. See, hetero means different. Hetero means
Yes.
different. Homo means
Different.
same. So what
Same.
is the basic difference here? Let's suppose I'll be taking two components. A is a pure substance, B is a pure substance. And if it is homogeneous, the particles of A will be properly dissolved in the particles of B. Therefore, we will not be able to distinguish between the particles of both the compounds. Therefore, I'm saying homo, same. It appears to be same, right? Whereas
Yes,
if
ma'am.
A and B are heterogeneous mixture, they are giving us a heterogeneous mixture. The particles of A or the particles of B will not dissolve in the particles of other component, but rather will be dispersed or suspended in the particles of other component. That is why we are able to distinguish between the particles of different components in a heterogeneous mixture. This is the
Yes, ma'am.
basic point of differentiation. Okay. Now,
Yes,
based
ma'am.
on this property, we will have other properties of difference. Example, in case of homogeneous mixture, we have a uniformity or there is a even distribution. If you are having salt and water, you will taste the same throughout if you have mixed them properly, right? It
Yes.
will taste the same throughout. Whereas if you are having sand and water, I think in some amount of water, the
Then will be less.
concentration of, yes, and in some it will be more. Why? Because there is no even distribution. So this is a second point. Okay. The third point, what could be other points based on the homo and the heterogeneous difference? All of it I have already explained, dissolving, even distribution, okay, particles clearly visible or not. So all of these are basic points of difference here, okay? Now I'm starting with the homogeneous mixture. Should I start with that?
Yes, ma'am.
Fine. Homogeneous. See, homogeneous mixture is referred to as a solution. Homogeneous mixture is referred to as a solution. A solution, see, when we are saying a mixture, we say we are having two components. We are just considering the mixture which is having two pure substances. Okay. So in case of solution also, there will be two pure substances, A and B. One will be
Yes,
the
ma'am.
solute and the other will be the solvent. The two components of a solution are referred to as solute and solvent. Generally, the one which is in less quantity is the solute. The one in the more quantity is referred to as the solvent. Because we
Sorry.
are saying we can have a variable composition. Okay. Now, since it's a homogeneous mixture, I think we will already say that the particles of the A will completely dissolve in the particles of the B. Therefore, complete
Yes, ma'am.
dissolving will take place. Okay, complete dissolving will take place. Now, since this is also matter, although impure matter, but A and B are pure matter, right? They will have some of the physical states. The solute could be solid, liquid, gaseous. The solvent could be solid, liquid, gaseous, right?
Yes, ma'am.
Now we can have different combinations. At your level, we are just discussing the solute of different forms, but the solvent is just taken as the liquid. The solvent is just taken as the liquid. I hope that
Liquid.
is clear to you. And
Yes.
generally, the physical state of the solution is determined by the physical state of the solvent.
Yes, ma'am.
Clear?
Yes, ma'am.
Fine. Now, other point, not all the solutions are liquid. We can also have solid solutions. We can also have the gaseous solutions. I'm quickly coming to that first. Okay. So liquid solutions, bache. Liquid solution, I think you will say the example salt water,
Yes, ma'am.
right? When you mix it properly, I think it is even, right? It is even
Yes,
throughout. You
ma'am.
cannot really differentiate it, right? So salt water is the example. Now, the important point here is that when we are coming to the solid solution, okay, bacha, these two examples are just there. Otherwise, we are having liquid solution in the syllabus. So when we are talking about the solid solution, alloys are the best example for solid solutions. Why? We will discuss. What is an alloy? I think mixture of
A
two or
mixture of two metals.
yes. I can simply say mixture of two elements. We can also have
Yes.
non-metal, right? We can have
Yes.
metal, non-metal, metal, metal. All of these could be mixed alloy.
Yes.
Okay. So metals are obviously solid. We have already discussed this in the property. So can I
Yes.
say that the solution is nothing but the solid form? Okay.
Yes.
So alloys are examples of solid solutions. Now see, alloys is very important topic and we will discuss why. Please pay attention. If I'm saying alloy is a solution, it is a mixture, it is a homogeneous mixture. If it is
Yes,
a
ma'am.
homogeneous mixture, I'm considering two elements here, A and B, which are bonding together here. Okay. So they'll be bonding in a variable composition. Yes, in a variable composition. The important point, and since it's a mixture, it will having the properties of both of the constituting elements. Yes,
Yes, ma'am.
result of the properties. Just understand what I'm trying to say. Okay, result of the properties here. That's it. It should have physical bonding, right? It should have physical bonding.
Yes, ma'am.
It's a mixture. Now this is the point of exception here. In case of alloys, please understand this, bache. In case of alloys, the elements are bonded chemically to each other. What is the type of bonding? Chemically.
Chemical.
From this property, I can say that they are compounds.
Yes, ma'am.
But the most important part is this variable composition. And the property is not completely different or new. Based on these properties, the alloy is referred to as a
Mixture.
mixture. Is this point understood? Is this point
Yes, ma'am.
understood? Yes. Although this is the exceptional point here, but other properties are still same to that of mixture. Therefore, alloy is still a mixture with this point of exception. And if it is chemically bonded, can I say it cannot be removed or separated by physical methods of separation?
Yes, ma'am.
Chemical method needed. These 2 points are the exceptional point. Rest, these 2 points are similar to that of the mixture. Therefore, alloy
Yes,
is
ma'am.
a mixture. So I can ask the method, name one mixture, give me one example of a mixture which is having chemical bonding. Alloy, any alloy, okay? And is it clear, bache? And the example of the alloy, brass. So it is made by the mixture of copper plus zinc. Zinc is around 70%, okay? Sorry, no, yes, zinc is around 30%. Okay, copper is around 70%, zinc is around 30%. At times, I can also add 35% of zinc. I can add 65% of copper. Okay, so what I'm saying is that I'm having a variable composition. And why do we actually make alloys? We make alloys so that we can get the best properties of both the elements that we're mixing or of all the elements that we're mixing. That is the sole purpose of alloys, yes. And therefore, it's nothing
Yes,
but a
ma'am.
mixture. Property of mixture, right? Intermixing of the
Yes, ma'am.
properties, result of the property. Therefore, it's a mixture. Is this clear or not?
Yes, ma'am.
Fine. Now the gaseous solution. I'm saying alloy is a solid solution since it's the solution, it's a homogeneous mixture. If it's a homogeneous mixture, it's a mixture. If it's a mixture, it will have variable composition and it will have the properties as a result of both the constituting pure substances.
Yes, ma'am.
Fine. Gaseous solution, air. Air. We are studying this from the earlier classes. Air is a mixture of different gases. Air is a mixture of different gases, right? So air is a
Yes, ma'am.
mixture of different gases. What are the different gases here? So
Oxygen, nitrogen, carbon,
nitrogen, oxygen, carbon dioxide, yes, water, argon,
helium.
all other gases. Okay, but since therefore it's a mixture. They are not bonded chemically to each other. They are not bonded chemically to each other. Fine. Why is it fixed then? We have always learned that nitrogen is 78%, oxygen is 21%, carbon dioxide is 0.03%, H2O is something, okay, a very small amount. But why is it fixed then? Then if it is fixed, this is the main property of compounds. In case of alloys, there was variable composition. That is why we did not call them.
Ma'am, because it has the properties of all the gas.
In case of alloys, we did not call them a compound because it was having variable mixture, right? Variable
Yes.
composition. But in gaseous state, gaseous solution, the main property of compound is here. That is fixed composition. Then leave everything else. The main property of compounds is the fixed composition, right, bache? Then why not?
Yes.
Then why are we saying solution here?
Ma'am, because the air is made up of multiple gases, but they also show multiple properties. They
That's
combine
fine. That is
different
all
properties.
fine. The main point is fixed proportion. See what you are see. What happens? We don't really have a very fixed proportion. We are having a variable composition. If I'm talking about water, each and every droplet of water will have two atoms of hydrogen and bonded to one atom of oxygen. In case of air, we are having a variation. What kind of variation? Let's understand. Carbon dioxide levels can vary based on the pollution level. I think that is very well understood. Okay.
Yes,
Water level in the air vary based on the humidity level. We can have at times more amount of water in the atmosphere. At times we can also have very dry atmosphere. That is very less amount of water in the atmosphere, right?
yes,
Second, bache, oxygen's level is not fixed. When we go high up the altitude, the oxygen level decreases. When you go very down to the sea level, the oxygen level decreases. Are you getting this?
yes,
Near to the poles, the oxygen level keeps on decreasing. It is not fixed. It is not fixed. Just a second. Yes. Sorry for the disturbance. Yes. So the composition is not really fixed. Is that clear?
yes, ma'am.
That is why we are saying air is having a variable mixture. It is a mixture of all the gases. It is having properties of all the gases present in the atmosphere, and that's it. Therefore, air is a gaseous solution. What is the state of the components here? That is the gaseous state. Therefore, we are saying it's a gaseous solution. What is the if it's a solution? What is the solute and the solvent here?
Um, if air is a solution,
There should be some solute and solvent, right?
yes,
If
ma'am.
it's a solution, yes.
The gases are
See,
both, I
bache,
guess.
the solvent is obviously the one in the larger quantity. Can I say nitrogen is the solvent?
Yes, ma'am.
And all of the gases will act as a solute.
Okay, ma'am.
Okay. In case of alloy, what is the solute and the solvent? Since we have established that alloys are solutions, what is the solute and the solvent in brass alloy?
Copper would be the solvent and zinc would be the solute.
Correct. Any confusion in this, bache? Any
No,
confusion?
ma'am.
Fine. Now, I will be coming on to the liquid solutions now. Okay, we have to deal with something regarding the liquid solutions. Okay, that's it.
Salt water.
What sorry?
Salt water.
Yes, salt water is one of the best examples, basic example of this. Okay. The other two important solutions that we need to discuss is the tincture of iodine.
Iodine plus alcohol.
Yes. Tincture refers to alcohol. Okay. Iodine is a pure substance. It's an element. Alcohol is a compound. It's a pure substance. Okay. Both of them have been mixed together in some variable composition. Okay. We can have slightly variable composition. Okay. And both the properties of both of them we can be, we are seeing in the mixture. Fine. This is used as an antiseptic solution. Okay. Have you heard of the spirit?
Yes, ma'am.
It is like this. Okay. So antiseptic solution. Clear? Now, what is it? Alcohol is present in the liquid state. Yes. And iodine is present in the solid state. So therefore, it is a solution. Both of them mix properly. We can clearly see no distinction in the different particles. It is nothing but a homogeneous mixture, right? It is even throughout. Particles not visible. Let's talk about soft drinks. Let's talk about soft drinks.
Isn't that a gas solution?
Just a second. Can you just see? Yes. So we were talking about the soft drinks. Yes. They are also called as aerated drinks. Why?
Because it's a combination of air and the water, the
Yeah.
liquid.
Not air, but say air is a mixture of many gases. I'm saying the point here is that we are
The
adding
gas.
carbon dioxide. Yes. These are all carbonic drinks. We are having any solid liquid. Okay. In that, we are adding carbon dioxide. That is why we see those bubbles, right? Effervescence.
Yes.
It's carbonic drinks, it's aerated drinks, okay? And can I say it's a mixture? Yes, clearly it's a mixture. Carbon dioxide is a pure substance, other liquid is a pure substance. We are mixing them together. But what is the state here? This is in the gaseous form, and the liquid, I mean, the solvent is in the liquid form, right? So we are getting what
Yes.
side of the solution? Gaseous dissolved in the liquid part. So carbon dioxide becomes the solute, the other liquid is the solvent. Is this clear?
Yes, ma'am.
Fine. Now we are coming on to the next, the part that is properties of solution. We have understood the examples here. We are just having 4 properties, okay? The first one, what is the nature of this? Can I say it is homogeneous? Yes, it is homogeneous,
Homogeneous.
okay? The second, see, why is it homogeneous? Because proper dissolving is taking place. I told you that is the basic point of difference. Why is
Yes, ma'am.
proper dissolving taking place? Because the particles would be very small in size. If the particles are this big in size, I'm very sure the dissolving cannot take place. That is why they are suspended. Okay. In case of solutions, the particle size is less than 1 nanometer.
1 meter.
That is very small. If the size is less than 1 nanometer, it will behave as a
Homogeneous.
solution. Okay, the particle size is less than 1 nanometer, it will behave as a solution. Okay. The third point is that since proper dissolving has taken place, even if I keep the mixture for some time, the components of the mixture will not separate out. Why? Because proper dissolving has taken place. Clear?
Yes.
So if this is called as a stable mixture. They are a stable mixture. What is a stable? I will quickly explain you. If I have any mixture, okay, and if I leave the mixture for some time as it is undisturbed, if the one component settles down at the bottom and the other remains up, that means it is unstable because it is separating out, right? Yes or
Yes,
no?
ma'am.
Since we do not see this in the solution, that is why we are saying it is a stable mixture.
Stable mixture.
Please try to understand this. If let's suppose this is the solution, okay? And let's suppose one component settles down here and the other remains here. You must have seen water and mud. The mud will settle
Yes.
down, the sand will stay, right? And then we can filter that out. Why? Because this is still at the bottom. We can filter water, right? In
Yes,
case
ma'am.
of unstable mixtures, we can use filtration. But since if it is not even settling down, this is as it is proper as a one solution, I cannot use filtration there. Yes.
Yes, ma'am.
So therefore, when the mixture is stable, filtration cannot be used. Is it clear?
Yes, ma'am.
And the last point is the Tyndall effect. Solutions do not show Tyndall effect. Do not show. Why? What is Tyndall effect? Let's quickly understand. We have a solution. It will be having some particles, right?
Yes,
And
ma'am.
we know the particle size is very small. Right? Let's imagine you are going in on a road which is very like less crowded, almost no crowd there, or even if the crowd is a bicycle is going or very small people are going, that's it. You will face no hindrance in going through that, right? You will face no
Yes.
hindrance. Okay, what is Tyndall effect? I say that the light is coming, the beam or the ray of light is coming, okay, and since the particles are so small, they will not really hinder the path of the light. Therefore, they will not scatter the light. If the light is not scattered, it will go as it is. It will
Yes,
go
ma'am.
as it is. And the light will is not scattered. Therefore, the path of the light will not be visible. We are only able to see the path of the light once it gets scattered. Are you getting
Yes, ma'am.
that? Therefore, this is Tyndall effect and it does not scatter the light. Therefore, no path light visible. Therefore, does not show the Tyndall effect. Why is it happening? All because of the small solution particle size of the solution.
Okay, ma'am.
Any confusion here? The solution is completed.
Yes, ma'am. No confusion.
No. Should I quickly complete the suspension and the colloid?
Okay, ma'am.
Are you okay with that?
Yes, ma'am.
If you have understood this, we'll quickly complete that. Heterogeneous mixture. Heterogeneous, I've already told you the particle size would be greater because no dissolving actually takes place, only dispersion or the suspension of the particles take place, and we can see the particles, in a distinguishable form. Okay. Now see, it is of 2 types:
Suspension and
suspension and colloids.
color.
And one thing, bache, this solution which is homogeneous solution, yes, okay, it
Yes.
is also referred to as a true solution. What is it referred to as?
True solution.
True solution. If I'm saying there's a true solution, I mean the solution is homogeneous in nature. Okay.
Yes.
Why I'm telling you this? Because at times colloids is also referred to as a colloidal solution. And this is heterogeneous in nature. Okay, colloidal solution or colloids. Here, first
Yes,
I'm
ma'am.
coming to suspension. Suspension is the same thing. We don't have much discussion here. Suspension. Okay, the first property of suspension is it is heterogeneous in nature. What is the nature? Heterogeneous.
Yes, ma'am.
If it is heterogeneous in nature, that is very clear. Dissolving would not take place. And why would dissolving not take place? Because of the large particle size. Let's see what is the particle size here. The particles are greater than 1000 nanometer. You can see the difference. Yes.
Yes, ma'am.
And the third is that since the particles are so big in size, no dissolving takes
They
place.
should.
It is very obvious that if I keep them as it is, they will separate out, the mud and
Yes, ma'am.
water. So can I
They're
call it?
unstable.
Yes, unstable mixture. And if it's an unstable mixture, filtration can be used.
Used to separate.
Yes. I think you would remember this very simple experiment that we used to perform in class 6 or 7. Sedimentation, decantation. If the
Yes, ma'am.
mud sediments at the bottom of the container, we can then filter it, right? That's the same thing here.
Yes.
And see here, the particles are big in size, therefore they will scatter the beam of light. And therefore the
Yes.
path light will be visible. Tyndall effect shown by the suspension. These are the 4 properties of suspension. Last point here. Let's suppose we have this mud and water, okay? And if it
Yes.
is in a mixture form, I mix it properly, okay? After some time, if I leave it undisturbed, I think you will now tell me that the mud will settle down at the bottom and the water will remain here. Yes.
Yes, ma'am.
Now it is no longer a suspension. See, the mixture has broken, right? The mixture
Yes,
has
ma'am.
broken here. It is no longer a suspension. And if it is no longer a suspension, it will not show the properties of the suspension. Therefore, it will not show.
Tyndall effect.
Is it understood, bache?
Yes, ma'am.
Okay. This is asked in many questions. Let's suppose we keep chalk powder and water. The mixture is suspension in nature. Okay. And if I leave it for some time, will it really scatter the beam of light now? No, it will not scatter. Earlier, it will scatter when it is in the mixture form. But later on, it will not scatter. And what are the examples here? Chalk powder plus water,
Chalk
mud plus
powder.
water. Okay, all of these are examples of this thing, suspension. Fine. The third, any confusion in the suspension part?
No, ma'am.
No. The third is the colloid or the colloidal solution.
Yes,
It
ma'am.
appears to be homogeneous,
But it's
but is heterogeneous. Okay. Appears to be homogeneous, but is actually at the microscopic level, it is still heterogeneous. Heterogeneous simply means no dissolving. No dissolving. The particles are still dispersed. Okay. Why does that happen? The particle size is between 1 to 1000 nanometer. You can see between both of them.
Yes, ma'am.
Yep. And if the particle size is this much, it will not settle down at the bottom if it is left undisturbed. Therefore, it is
It's
still
stable.
a stable mixture. And if it's a stable mixture, no filtration. Clear? But
Yes.
since the particle size is greater than that of the solution but smaller than that of the suspension, Tyndall effect is shown by this. Clear?
Yes,
Clear?
ma'am.
Now, the next part, the last point regarding the colloid. Colloid, again, since it's a mixture, it will be having 2 components, A and B. The state of the A could be anything solid, liquid, gaseous. The state of B could be solid, liquid, gaseous, right? Based on different
Yes.
combinations, I will have different colloids. Based on different combinations, I will have different colloids. Okay. So the one which is in a smaller quantity of behaving like the solute, okay, is referred to as the dispersing medium. Dispersion phase. Okay. The one which is in the lesser quantity or behaving like a solute. Okay. And the one which is in the greater quantity or behaving like a solvent is
Dispersing
referred.
medium.
Yes. Yeah. Medium means what? The solvent, the
The
particles
thing
in
that
which the particles, yes, in which something is happening. You can clearly understand there. Okay. So based on that, we have different types of colloids. What are these different types? We'll quickly go through them. That's it. Liquid gas, aerosol, solid gas, aerosol, that's it. You can go through that. Any problem, please ask.
Ma'am, anything combined with a gas is an aerosol, right?
This will be called as the liquid aerosol and this will be called as the solid aerosol.
Solid aerosol.
Just, yeah, at times it is referred to as solid and liquid, just to differentiate what is the phase here, okay?
Ma'am, sol means solution, right?
No. Sol does not mean solution. That's different. Solution is a homogeneous mixture. Sol is just a colloid here, okay?
Okay.
See, when you write solution in the short form, it is like this. It's different.
Okay. Okay, ma'am, it's clear.
Fine, that's it. I want to quickly discuss this one example with you here, and that is very important. See, this A part, do not focus on the description here, just focus on this A part, okay, is any solution, I mean any mixture here. This B part is any mixture here, right? The B
Yes,
part
ma'am.
is showing the Tyndall effect, the A part is not showing the Tyndall effect. Can you tell me what type of mixture is the A part here?
Homogeneous. I mean,
And what
like,
is it? Solution, right?
yes, it
And
is.
what is the first part? That is copper sulfate solution. So if I ask you what is the nature of copper sulfate solution, you will tell me it is a homogeneous mixture.
Homogeneous.
Just based on this part, the question could be framed. Okay,
Yes, ma'am.
fine. The last two topics are left for this, and that is the physical change and the chemical change, and the last is the concentration of the solution. Concentration I'll be dealing with in the next class. Can I just quickly finish the chemical change and the physical change right now?
Yes, ma'am.
Do you have any idea regarding physical or chemical change?
Physical change are the processes which do not require like any change in the physical composition of a substance, but chemical change,
Not physical,
physical
chemical composition.
properties, chemical
Chemical
properties.
composition of the substance. Fine, good. Let's suppose the simple point. I've always given this example. This is a square or rectangle, whatever you want to imagine it, okay? And if I divide this into two, it becomes like this. It is still is a rectangle. The shape or the size has changed, but it still is a rectangle. Fine.
Okay.
So some change is taking place here. But if I say this is a square, now it has become this. Is this the square here? No, not really, right? So the chemical composition is changed. Here the shape or the size is changed, okay? So the change can happen, but the change in which the change in the chemical composition is not taking place is a physical change. And the change in which the change in the chemical composition is taking place is a chemical change. Simple. The simplest point is that in chemical change, the change in the chemical composition will take place, okay? Clear? And if the chemical change is taking place, okay, if the composition is changing, therefore I will have to call it something else. Therefore, new substance or product is formed in the chemical change. Why? Because the composition is changed. It will have to be called something else, right?
Yes, ma'am.
And if it is irreversible, what kind of change it is? Irreversible. Whereas
Irreversible.
in case of physical change, what is it? No new substance.
No
Yes,
new substance.
irreversible. Okay. And if the shape, the size, or the physical state of anything is changing, it comes under physical change. Shape, size, or physical state is changing, it comes under physical change. I'll
Physical
quickly
change.
go through that. See like this. Let's suppose, bache, this is ice. This is ice. Okay. Its composition is what? H2O. H2O,
Yes,
right?
ma'am.
Let's suppose these are the particles of H2O, H2O, H2O arranged very closely because it's a solid, right?
Yes, ma'am.
It changes to liquid. Now the particles are still same, that is H2O, H2O, but the distance between them has changed. The composition is still same, right? What is this? Change in the physical state, but what type of change it is? Physical change. Are you getting this?
Yes, ma'am.
Right? But if I burn a piece of wood, it will change to ashes and the carbon dioxide. Substance
Yes.
new form because chemical composition is changed. It is a chemical change. Here,
Yes,
iron
ma'am.
rod. Let's suppose we have an iron rod. If we cut that into two pieces or we twist it, that's a physical change. But if it is undergoing rusting, it's a chemical change. Rusting is a chemical change. Fine. Any problem in that?
Yes. No, ma'am.
We have been talked about. No, I'll give you that in the homework to try that. There's a question called as. No, we'll discuss it right now only. I don't think there's any sense in it. See, come here quickly. The interconversion of state is a physical change because these changes occur without a change in the composition and no change in the chemical nature of the substance. I think that would be clear. Ice, water, and water vapor look different and display different. The physical properties can still be different. Why? Because the physical state is different, but
Yes,
the
ma'am.
chemical properties will still be the same.
They are still
Okay.
H2O.
Yeah. Both water and cooking oil are liquid, but their chemical properties are different. They appear to be liquid. I mean, they appear to be in the same physical state, but the chemical properties are different because they have different chemical composition. Okay.
Yes, ma'am.
It is this chemical property of oil that makes it different from water. Burning is a chemical change. During this process, one substance reacts. And chemical composition, again, same. Okay. This is
Yes,
important, Bache. During burning of candle, both physical and chemical changes take place. Can you explain how?
physical change, the melting of wax, and the chemical change, the burning of the wick.
Burning of the wick, right. So the melting of the wax, okay. The change in the shape of the candle, yes. All of that is
Yes.
physical change. And the reaction which is really leading to the burning of the candle, okay, is the
The wick.
chemical change. Fine. Yes, the wick combining with the oxygen to form the flame and give off carbon dioxide is a chemical change. Good. So cutting of trees, physical.
Yes.
Melting of butter in a pan.
Physical.
Rusting of almira.
Chemical.
Boiling of water to form steam.
Physical.
Boiling. Steam is still H2O. Physical or chemical?
Ma'am, it's still steam is also H2O, right? Water vapor is still
Right.
H2O.
So what it should be? Physical, right?
Physical. Physical.
Okay. I thought you said chemical. Sorry for that if you said physical. Passing of electric current.